Hi, welcome to the second of our videos, and this one we're covering Microsoft Azure Stack HCI Switchless solutions, and we'll be going into how you configure, design, manage and monitor an Azure Stack 2 to 5 node switchless configuration.
My name's Ian Sagan. I work for Marvell as a pre-sales engineer. I'd just like to introduce you to Terry Story from Accutech, the Chief Cloud Officer.
Welcome to our second video on Azure Stack HCI and switchless RDMA networking. This configuration option is becoming increasingly popular due to substantially lowering costs and complexity, no compromise to performance and stability.
To understand what is RDMA, Remote Direct Memory Access, please see our first video. This goes into explain how RDMA works and also the differences between RoCE and iWARP.
There are two Dell EMC HCI offerings, one based on Windows Server 2019 HCI and the second based on Azure Stack HCI, a unique product in its own right. Going to the first, Windows Server 2019 HCI, this supports disconnected from Azure and connected to Azure scenarios and has less need for Azure hybrid management capabilities. This also leverages traditional Windows Server 2019 data center licensing per core, providing access to unlimited VMs. And it's great to run Hyper-V virtual machines at the lowest cost in the simplest way with no bells and whistles on premise. Business as usual, per se. And through Windows Admin Center provides individual updates for hardware and software through cluster-aware updating. Alternatively, Dell provides the Azure Stack HCI, which requires a connection to Azure and supports native integration with Azure for management and governance at scale. This also supports automated guided cluster creation and one-click cluster-aware updates, bringing enterprise-level capabilities to Azure Stack HCI. This supports new capabilities such as stretch clustering, faster single storage spaces on reboot of a node after patching, making all that far better and simpler than ever before. This also brings a new licensing model based on Azure subscription to simplify access to next releases and rolling feature upgrades with no downtime, delivering on the evergreen IT promise. What is a switchless Azure Stack HCI configuration? You can see a 3-node configuration in front of you. This has an external network for management and desktop access to highly available virtual machines and a back-end high-performance RDMA interconnect for cluster communication, live migration, and Spaces Direct networks. A point to note here, switchless is always a non-converged configuration. The external network always connects to the top-rack switch, typically at dual 1 gig or dual 10 gig speeds. The back-end network doesn't require high-performance 25 gig switch for 2 to 5 node configurations, reducing cost and complexity. For higher cluster nodes, you do require switches. These must be connected in a full mesh topology, not a daisy chain with point-to-point single or dual connection pathing between each node.
So thank you, Terry. Now I'd just like to go into the hardware required and how you cable and configure the Azure Stack from a 2 to 5 node cluster. On here we're starting with a simple 2-node configuration, which is the majority of small branch office environments, and we're using the Dell AX-R740XD server, which is specifically designed for Azure Stack. All the hardware, firmware and drivers are all pre-configured and pre-tested for Azure Stack. This makes it a lot simpler to implement and configure, and also the support is fully certified and tested for Azure Stack. And on here we're using the Marvell FastLinQ QL41262 adapters, and these are providing dual 25 gig capability using RDMA with iWARP to connect both links. And then we're connecting these together using either direct attached copper cables or active optical cables to connect the two servers together. And this back-end network will be used for live migration traffic, storage traffic, and in between the cluster traffic. And then on here we've got two external links using the Marvell FastLinQ RNDCs, the QL41164s, and then these are connected for your uplinks into your customer network for external traffic. And each link is set up as a separate subnet between here, so that way Azure Stack knows both links are available. This is how Azure Stack load balances across the RDMA backend network. So basically, if you've got two links, the Azure Stack will do the load balancing across the links. It also monitors the links, and if there's a path failure, it will then automatically reroute traffic across the available link. So, but what it doesn't do is push any traffic across the external 1 or 10 gig links, because we've still got 25 gig available on here. And so Azure Stack will monitor the networks, and it will use the best available paths. And because we're using the RDMA with iWARP, again, it'll be using the low latency, high performance traffic across here. Once that link becomes available again, it will start pushing the data across that link to be able to get full performance across there. So now we're scaling up to an Azure Stack 3-node design. This one's just using a single NIC configuration, so it's like a lower cost configuration. But each server can talk to every other server. We always create a full mesh. And we don't create a path through these network adapters, because each network adapter is in a separate subnet. We don't create a route between here. So what happens if we get a failure between the links? Basically, if we get a path failure on here, this link, instead of the data going across here, we'll still keep the cluster, but the traffic, instead of using that link, it will go across the external 1 or 10 gig link to be able to connect it together. So we don't lose our heartbeats between here. We don't have to create a rebuild. So we still get full availability. It's just the performance will lower down because we're not going to use RDMA traffic across here. So we'd advise using a 10 gig link definitely as an uplink if you only have a single connection on here. To provide a higher availability design, we'd advise using dual NICs, and this way we provide always two paths between each server. So even if we lost this link, we could still talk across this link to the server. So even if we lost a network card or a link, we'd still keep using our high performance 25 gig RDMA traffic for live migrations and storage traffic in the back end. We wouldn't need to use our external 1 or 10 gig networks to provide there. So this provides a lot higher availability, a lot higher resiliency, and without requiring switches, of course, for the back-end network. And again, we can scale up to a 4-node cluster. This one is only a single connection between each server. We're still creating a full mesh, so every server can talk to every other server, but we only have a single connection between each server. But again, if one of those links failed, we can still use the external uplinks to keep the full availability running. So what we recommend really for highest availability for a 4-node design, again, we use the Marvell FastLinQ adapters. We use 3 of these per server, and we can create a dual full mesh between each server. So we have a link up here. We also have a link between here and here. So again, we could lose a network card, we could lose a network port, and we still keep that high performance backend network running at over 25 gig throughput. And again, we can pre-configure all these IP addresses for each network, and we can use a PowerShell script to go off and pre-configure all the IP addresses and subnets on here. And then we can also run test scripts as well to check all the links are up and running. And then we can run tests using VM Fleet and other performance testing just to check that high performance dedicated network in the back end. Then we can also scale up even to a 5-node design. So again, even using switchless provides the high availability or the scalability to go from a 2 to 5-node design. With this one, we've only got single connectivity between it. If you went up to quad port adapters, we could start even having dual 5-node designs. So although we're not using switches, we're still providing high availability, and we're still providing the scalability to go up to a 5-node design as well. So I hope you found this useful. Terry's now going to go into some more detail of how you can monitor it using the Azure Stack tools.
Let's come back around on everything we've shown so far. In front of you, this failover cluster manager, you'll see the two nodes. You'll see that the cluster share volumes are owned respectively by each node, optimized for VM fleet. You'll see the typical collect volume. And if we look at the networking, we have a typical naming for SP1, SP2. Each represents a 25 gig network. This is a dual 25 gig back-to-back connection between the two nodes. And if we then disable the RDMA network on node 1, obviously the uplink will then disappear, and you'll see that the RDMA network will go down on both nodes. But the system continues to run. This is the most important part of the message. You have a dual 1 gig network, which is the front end of the cluster. This is where the cluster will talk out and resolve to DNS, access Active Directory, for Kerberos to support live migration, and desktops can access virtual machines. And what you'll find now, with RDMA disabled and the high-speed interlink between the two nodes down, the VMs still run. They still continue. They're still running on the same node. The desks, the CSVs are still running on the same node. The ownership stays the same. It still continues. Now, if we go to the roles and we look at live migration, and we do a live migration, you'll see this will also continue to function. The main thing here is that everything continues to run business as usual. It's just slower. There's no RDMA between the two nodes, and CPU is going to be higher when you're doing live migrations and you're doing normal kind of cluster type comms between the two nodes, because everything's going over the dual 1 gig network. So see, it's still running, still functioning. It's just a lot slower. Okay, so let's wait for this live migration to complete, and then we'll go back and we'll enable RDMA and we'll compare. But the main thing is that you can have failures on the network adapter that provides RDMA, the interlink between the two nodes, whether it's a port failure, a cable failure, a complete network adapter failure, in this, as is this example, and the system will continue running. The cluster network logic takes care of it. It's always monitoring and switching backwards and forwards. So let's go back to the network. You'll see the RDMA networks are down. So let's now re-enable these adapters, and you'll see these dynamically come back online again. And with that done, let's now go to that same virtual machine and complete a live migration again. And you'll see this time it'll just dynamically switch and use RDMA. The reason why you know that is because it's a lot quicker. So now, it's quicker to jump in live migration, and literally it is done. So the point of this part of the demonstration is to show that with a back-to-back 2-node Azure Stack HCI or 3-node, 4-node, and 5-node, if you have a particular network adapter failure, which is the primary RDMA network, the system will automatically detect that and use the other networks available in the cluster. So the rules are this: it will look for RDMA first, then the next fastest, and then a network adapter that doesn't have a default gateway, and to use as its path between the cluster, the live migration network, or the cluster network, the cluster heartbeat.
So thank you, Terry, for that great demonstration. Now I'd just like to show you where you can find out more information and just summarize the points that we've gone through. Please go and visit the Dell Technologies page to understand the Azure Stack HCI configurations. This goes into a lot of detail on what hardware requires and what the configuration is, and it talks you through it. You can either go into the solution architecture for a switched environment, or you can have a look at the switchless storage networking. And again, this explains what the hardware is, how to configure either a single mesh topology or a dual mesh topology, and it goes into the topology diagrams for a 2, 3 and 4 node configuration. So if we look at the full mesh topology, again it shows you how the cabling works. Either this is a 3 node configuration, and then we can go into more, and it shows you what hardware you need and how many adapters you require. And again, it's using the QLogic FastLinQ QL41262 adapters, and it shows you how many of those you need and how to configure them and then how to set them up. So there's a lot of really good information on here to help as well. So please have a look at this website as well. So just to summarize, best practice for the Azure Stack HCI switchless environments: order the Dell AX node servers with the Marvell QLogic FastLinQ QL41262 dual port 1025 gig CNAs. As we mentioned, they support remote direct memory access either over RoCE or iWARP, but for simplicity we advise using iWARP. It's a lot simpler to implement, and it's not just us, it's also Microsoft advise that as well on all their blogs. So what we can do is we need to enable from live migration to use SMB, server message block, which will implement RDMA across the backend network. And because we've got this high performance dedicated network, we can increase the number of concurrent live migrations, say from 2 VMs up to 8 or 10 VMs, to get full performance out of the dual 25 gig RDMA network. So again, configure each port into a separate subnet, an IPv4 subnet connection. This makes it simple to configure. We don't need to use IPv6 because this is just for server-to-server connectivity within the cluster. We're not going external on here at all. We can also disable PTP, Precision Time Protocol, as timestamping isn't required for the server-to-server connectivity. Again, this can reduce latency and the amount of traffic going across the live migration backend network. And again, we can configure the backend network for large jumbo frame size packets to get the best performance out of this network. So just to summarize the benefits of the switchless Azure Stack HCI, basically the cost saving is probably the biggest advantage that most customers want to see, because you don't have to buy the expensive dual 25 gig network switches, or in the future even 25, 50 or 100 gig switches, because you connect them back to back. So as well as the reduced cost of the purchase of the switches, we're also making it a lot simpler to manage. You don't need to have additional networking skills to configure features like data center bridging, which is required for RDMA with RoCE if you use that. So again, you don't need to be a network expert because you're just connecting it all point to point without any back-end switches. This also allows you to be able to upgrade your network on the back end faster as well. So when features like storage class memory is supported and other faster SSD storage, again, it makes it easy to upgrade it. You can just upgrade the network adapters either up to 25 to 50 to 100. And again, you don't have to replace any switches or do any additional configuration on the network. And then in the future, when you get quad 25 gig adapters, again, we can have more connectivity and we don't need to then have additional PCIe slots. So we can also shrink down the size of the servers and we can expand the number of connections between it, or the number of nodes in the cluster. So again, we make it very simple to be able to configure, cable and manage the whole configuration. There are test scripts, and you can run bench performance testing, and again it makes it very easy to scale from 2 to 5 node, either single, or we recommend dual connectivity at the back end across your Azure Stack HCI cluster. So thank you for listening. We hope you found this useful, and again, if you want any more information, please contact myself or Terry and we can go into more detail on this. Thank you.